Thank you. Next is Jean-Pierre Delplanque to talk about hydro.
Yeah, so like Peter was saying, there is an even younger kid on the block. We started this effort revolving around small hydro less than a year ago. Lon House, myself, Brian Jenkins of the Energy Institute, and Kees van Dam of the Wind Energy Collaborative, and that will become a little bit more obvious why that was relevant here to have somebody from wind energy involved. So because we've been in existence for less than a year, there is very little to report. We're all about perspectives and challenges and what we can bring to the table. You notice that the small in small hydro is italicized here. That's our way to focus the topic of our endeavors, and I'll say more about that in a few minutes. So the way small hydro is typically defined, small hydropower, is by looking at the size of installations. So below 30 megawatts in the US is considered small hydro, below 10 megawatts in other parts of the world. That can be further subdivided in mini, micro, even pico hydropower. The idea of the collaborative is to focus on all small hydro, but of course also to focus it and narrow it so that we have achievable goals within a reasonable time, even if in the longer term we are expecting to expand to other areas. What you're seeing here are the summary of a study that was conducted about 6 years ago. It's out of a report by Mike Kane to the CEC. And this actually summarizes some of the numbers that have been gathered by the Idaho National Lab regarding hydropower in the US. And here we extracted the numbers that are relevant to California and that are limited to small hydropower, which is the work that Mike Kane did. From impoundments and natural waterways, 1,900 megawatts of potential hydropower in California with an estimated annual energy production of 5,800, 5,900 gigawatt per year. If you add to that constructed open conduit in water delivery system, that's another 255 megawatts. The total potential, adding those two up, of 2,200 megawatts, according to a study of the National Hydropower Association, could serve 600,000 households, offset potentially 300 million tons of carbon dioxide per year, and generate up to 6,500 family supporting jobs. So this is not something that's to sneeze at. The question that comes up presumably is why now? This is not a new technology, although the size looking at small hydro is newer than hydro overhaul, but definitely not a new technology. So why is the time right now? There is, of course, a confluence of events that has converged to that. There are some new water agency feed-in tariffs. Of course, the influence of the RPS is not negligible here. And there are also some incentives from legislation. We're thinking here about SB 412 in 2009 that allowed more flexibility in the way we look at the way incentives are considered in terms, particularly, of their potential to reduce greenhouse gases. And there's been also some advances technologically that have allowed to develop new hydro generators that might be more efficient, more adapted, just better for energy generation at that scale using small hydropower. Now, I said we were going to look at a specific application, defined tasks, defined challenges that we can tackle in the foreseeable future, in the short term. And the one that we're looking at right now is that of in-conduit small hydropower. So this potential was actually not covered in the numbers that I showed earlier. The man-made, the 255 megawatts that were described in the man-made canals, we're actually looking at non-pressurized conduits, open channels or even pipelines that are not completely full. Here we're looking at water distribution system with pressurized pipes. The in those distribution systems, it is critical to maintain the pressure in the system at adequate levels. And hydrostatic tells us that even 1 foot drop in elevation is going to increase the pressure by 0.4 psi's. And so any significant change in elevation is going to require that that pressure be compensated for if we want to keep the system working adequately. Typically, the way this is done is essentially putting a valve on the system. And you have a pressure reduction valve, and essentially that's wasted energy. That's energy that's going to be dissipated as heat, as noise. It's not being used. Instead, what could be done is run the water through a small hydroelectric generator, turbine and generator, and recover some of that energy. That's what we're interested in. Now the challenges that are faced here when trying to develop this type of small hydropower, they're in line with the type of challenges that you've heard about already, and I'm sure you'll hear again about the Wind Collaborative. Defining the market, because we're starting up, is of course necessary here. The interconnection requirement, because we're working with small generators, are complicated. They're always complicated. They are proportionally more complicated when we're looking at smaller generators. The various incentives that exist, both at the federal level and more recently at the state level, we talked about SB 412, for instance, how those come into play, that needs to be evaluated. FERC licensing is a potential issue because even though small hydro is categorically exempt, there are still some process that needs to, installers will need to go through. That process at this stage is still complex and costly, maybe to the extent that it could be prohibitive, and that needs to be addressed. Maybe the collaborative could contribute recommendations towards that. And then the technology side, of course, needs to be dealt with also. The type we're hearing earlier about technology neutral assessments, it's very important here also, depending on the type of hydropower that we're interested in, the site, whether we're using or we have to use a low head, high flow rate, or high head, low flow rate type of turbine, which one is appropriate, the type of issues that are specific to the fact that these will be installed in a water distribution system. Of course, we don't have to worry about fish injury, but there are other issues that potentially needs to be addressed also in terms of water quality, for instance. All of these have to be assessed. So the vision for this new collaborative is, again, very in line with what has been discussed before that has been implemented for the other collaboratives, and they're listed here. We bring together all the stakeholders. That's what we want to do to enable the development of new sustainable hydro energy resources in California with an initial focus on small hydropower. In the longer term, we could address other issues extended to larger hydropower, or even in the much longer term, marine and hydrokinetic applications as well. That would be a natural follow-up in the longer term. Another point that needs to be made here is the role that small hydropower in general, but small hydropower in particular, can play in terms of storage and the integration that is going to meet, able to meet with, in collaboration with the other organizations that you've just heard about. This is, again, a technology that's not new by itself, but the scale that we're thinking about here is new, and the associated regulatory and technical challenges are new also. Thank you.